Here are some examples of reducing. So this first example is you have a base raised to a power. And what you want to be careful of is you do this negative last. You're doing the exponent piece first. So what this is saying is negative 3 times negative 3 times negative 3 is negative 27. And then you have this negative still in front. So now you think of that negative in front as a multiplication of negative 1. So negative 1 times negative 27 equals a positive 27. The second example is two exponential terms dividing each other. So one thing you can do is you can reduce right away. You can divide the 6 and the 9 by 3. So this becomes a 2, that becomes a 3. You can also reduce the x's by a 1. By 1x, so that becomes a 1, and this becomes an x. Then you can reduce both of the y's by 5y, so y to the 5th divided by y to the 5th is 1, the same as that one. So what you're left with is 2 times 1 times 1, which is 2, over 3 times x times 1 is 3x. And there's your final answer, reduced form. The next example, be very careful with. There is a 2 out here, and you have to think of this as distributing into both pieces. So I'm going to leave everything else alone for right now, so that 5, and I'm going to distribute this 2 through. So it's saying x squared squared, and then y squared. Same thing happens in the denominator. I have a 2 that I have to distribute to the 5 and to the x squared. So that's 5 squared and x squared squared. So I'm going to leave this 5 alone for now. And now x squared squared is what we call power to a power. So x squared times x squared, we multiply those numbers together and get x to the 4th. And then y squared is still just y squared. And then down below, 5 times 5 is 25. And then x squared squared, so that's the same thing as this one up here. That's x to the 4th. Now we can do some reducing. We can reduce the 5 and the 25 by 5. So this becomes a 1, that becomes a 5. Then I can reduce the numerator and denominator by an x to the 4th. So that becomes a 1, that becomes a 1. So our final answer then is 1 times 1 times 2 is 2, and then 5 times 1 is 5. So there's your final answer, 2/5. Next example, if you remember negative exponents. Negative exponents we don't want to leave as a final answer. So you want to flip it. So it's going to become a fraction, 1 over b. And now that negative power becomes a positive 4th power. Next example has another negative power. So think about bringing this up to the top, and now it's a positive 2/3 power. And then we still have that 16. So now we're going to take care of that 2 times 2 times 2, which is 8. And then we haven't done anything with the 16 yet. So now we multiply those two numbers together. 16 times 8 is 128. Next example. You can do this problem 2 ways. One thing you can do is you can notice that this is a positive 1 power and this is a negative 4 power, but they have the same base. So if we have the same base, we can add their exponents. So these two exponents, so I have the base of 2, and then 1 plus negative 4. 1 plus negative 4 is negative 3. So this is negative 3. Now, just like what we've done before, this is a negative exponent here. So it's going to be 1 over 2, and now I change that to a positive 3. And now focus on the denominator. 2 times 2 times 2 is 8. So our answer is 1/8. Last example here. AB to the negative 1. You can do this problem 2 ways. You can distribute the negative through, so it becomes a to the negative 1 and b to the negative 1. And then remember, those are both negative powers, so it's 1 over a, and now a positive 1 power, and b as a positive 1 power. So it's 1 over a b.